Good morning. It's Mrs. Boland with Elements of Statistics, University of West Florida, and we're going to be doing some problem solving right now on discrete random variables, hopefully helping my students get prepared for their upcoming exam and understand the concepts a little bit better. So this is problem 1 of your homework assignment, and it says, let the random variable x be the number of rooms in a randomly chosen owner-occupied housing unit in a certain city. The distribution for the units is given below. So when you look, you will see that you have you have a distribution table. You have the value of x that the different values that x can assume. So there are obviously 3-bedroom units, 4-bedroom units, 5-bedroom units, 6-bedroom units, 7-bedroom units, 8-bedroom units, 9-bedroom units, and 10-bedroom units. So there are no 1-bedroom units. There are no 2-bedroom units. There are no 11, 12, 13, 14-bedroom units, okay? So that's what the random variable x denotes, is how many bedrooms are in a unit. And those are our available options. Then associated with each of those options is a probability, okay? And so that's P of x. So the probability that x equals 3 is actually 1, okay? So that's right here. That's right there. So it says the probability that x equals 3 is 0.1. The probability that x equals 4 is 0.22. The probability that x equals 5 is 0.4, or 40%. The probability that x equals 6, that we get 6 rooms, is 0.2, which is 20%. The probability that x equals 7 is 0.03, or 3%. The probability that x equals 8, or that we have 8 rooms, is 3%. The probability that x equals 9 is 0.01%. So the first question is x a discrete or continuous random variable? Remember, continuous means that we can measure infinitely to precision, okay? So if I ask how long something is, you could say 3 feet. But if I have a tie and I want to know which item is longer, and I measure both of them to the closest foot, and they're both 3 feet, then I need to measure to the inch. And if they're both precisely 3 feet 1 inch, then I need to take and do a more precise measurement. And I can keep measuring precisely to more to smaller units until I figure out which one is actually longer. Okay? Oops. I keep telling it not to put this up again, and it just doesn't listen. So when you have time or length or weight, those are examples of continuous random variables. Remember, money is always classified, even though you can only measure to the cent, money is always classified as a continuous random variable. So a discrete is something that you can count, and think of it kind of as whole numbers. So we can have a 3-bedroom unit, we can have a 4-bedroom, but we can't have a 3.5-bedroom unit. So this is a discrete random variable. So right here, this is a discrete random variable, okay? And so we're going to hit check answer, and we got that one correct. Alrighty, so let's move on to the next question. It says, what must the probability of choosing a unit with 10 rooms be? Okay, so let me see if I can copy this. I should have done this earlier. Let me just see if I can copy this over. Copy to where I'm going to be working. Let's see if that looks nice. Yeah, there we go. So now we have our information. So what the question is what is the probability that x equals 10? Remember that all probabilities must be between 0 and 1, okay? So all probabilities must be between 0 and 1. And also remember that the sum of all probabilities associated with x, the entire sample space, must equal 1. So using that second principle, that all probabilities must sum to 1, we're going to say, well, the probability that x equals 10 must equal 1 minus the probability that x is less than or equal to 9. Okay? So this would then be equal to 1 minus the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6 plus the probability that x equals 7 plus the probability that x equals 8 plus the probability that x equals 9. Okay? Because we know that the probability that x equals 3, 4, 5, 6, 7, 8, 9, and 10, the entire sample size, must sum to 1. Okay? So that tells me then that, let me see if I can move this up a little bit. That tells me then that if I subtract the probability that x equals 3, 4, 5, 6, 7, 8, or 9 from the number 1, what is left? The probability that x equals 10. Okay? So we're going to find this out. We're going to say the probability that x is less than or equal to 9, that is going to be equal to, I can see that my entries up there are a little bit doubled. So that's going to be 0.1. I'll have to pay attention to that. Plus 0.22 plus 0.4 plus 0.2 plus 0.03 plus 0.03 plus 0.01. And if we add those all together, yes, I have to grab a calculator real quick and punch all this in. It's 0.1 plus 0.22 plus 0.4 plus 0.2 plus 0.03 plus 0.03 plus 0.01 equals 0.99. So this is equal to 0.99. So therefore the probability that x is equal to 10 is equal to 1 minus 0.99. So that is equal to 0.01. Alrighty, let's go back and put that in and see if we got the right answer. So we're going to put in 0.01 and we're going to hit check answer, and we did get that correct. Terrific. So the next question is, part C, is what is the probability that a unit chosen at random was less than 5 rooms? Okay, so the probability that we have less than 5 rooms. So we're going to go back up to our chart up here, and let me just see if I can copy that chart one more time and do a better paste on that, because I did not like that. Copy. Let's see if that one, nope. Let's undo that and let's do one more paste option, see if this one, well, they're all doing double entries. So guys, you're just going to have to ignore the fact that we have double entries, okay? So the question is what's the probability that x is less than 5? So that is going to be simply equal to the probability that x equals 3 plus the probability that x equals 4. We can't use probability that x equals 0 or probability that x equals 1 or the probability that x equals 2 because it doesn't exist, okay? We only have 3, 4, 5, 6, 7, 8, 9, 10 room options. So this is going to be equal to 0.01 plus 0.22, which is 0.32. Okay, so we're going to take the probability associated with each event, whoops, yep, right there, and right there, add them together, and it's strictly less than 5, does not equal 5, does not equal 5. Okay, so we don't include 5, so it's only that x equals 3 or 4. That's how we get our answer. Okay, let's come over and put that in. So we'll put in a 0.32 and check our answers. Okay, we're on a roll. Let's look at the next problem. The next problem is, what is the probability that a unit chosen at random is not a 10-room unit? So the probability that it is not a 10-room unit. So that is probability that x does not equal 10. There's a couple of ways that we can look at this. If we're not going to have a 10-room unit, that means it can be anything but a 10-room unit, right? So that means that the probability of it not being a 10-room unit is equal to the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6 plus the probability that x equals 7 plus the probability that x equals 8 plus the probability that x equals 9. Okay, that's one way of doing it, and you could add all of those probabilities up. So that would be, I can scroll this up. Oh, I haven't created more space. Let me come down here and create more space real quick so I have access to that. Okay, so this is really equal to 0.1 plus 0.22 plus 0.4 plus 0.2 plus 0.03 plus 0.03 plus 0.01, and we've already added that up, and that's 0.99. Okay, that is one way of doing it. Another way of doing it is this, since we've already calculated what the probability is that x is equal to 10, we did that up here, and we said that the probability that x is equal to 10 is 0.01. That is right here. Okay, the probability that x equals 10, okay, is 0.01. Because we already have that, we could come right in here. We could say this is 0.01 right there, okay? And we could say that the probability that x does not equal 10 is equal to 1 minus the probability that x equals 10, because in that case, what do I have left? Everything left, right? So if I take the number 1, because that is the sum of all the probabilities in our sample space, added together, and I subtract off the one that it can't equal, then it must be what we have left is the probability of all the other events happening. So this is going to be equal to 1 minus 0.01, which is equal to 0.99. Both of those are correct ways of solving that question. So let's come back over here and put in 0.99 and check our answers. And we got that one correct also. Good job, team. Let's go on to the last problem, problem E. And it says, what is the probability that a unit chosen at random has more than 5 rooms? More than 5 rooms. So because the number 5 is kind of in the center, it's not really in the center, you can go, you can just simply say it's the probability of having a room that has 6, 7, 8, 9, or 10, and just add those together. Or you could say it's the probability that x is equal to, that x is greater than 5 rooms, is equal to 1 minus the probability of x equals 3, 4, and 5. Both of those are the same way of looking at the problem. So let's come up here and create, let's see if I still have that chart ready to paste. Let's just look and see. Yep, there we go. So we have right here, this is 0.01. So the question is what is the probability that x is greater than 5? So this is equal to the probability that x equals 6 can equal 5 because it's greater than 5. So it's x equals 6 plus the probability that x equals 7 plus the probability that x equals 8 plus the probability that x equals 9 plus the probability that x equals 10. Okay, so that is 0.2 plus 0.03 plus 0.03 plus 0.01 plus 0.01. And we're going to throw that in our calculator. So it's 0.2 plus 0.03 plus 0.03 plus 0.01 plus 0.01. And that is equal to 0.28. That is one way of solving this problem. Another option is saying that the probability, the probability that x is greater than 5 is also equal to 1 minus the probability that x is less than or equal to 5. Okay, using the complement. So let's see here. This is equal to 1 minus the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5. Okay, so that is going to be equal to 1 minus, let's see what we have here, x equals 3 is the probability of that is 0.1. Probability that x equals 4 is 0.22. And the probability that x equals 5 is 0.4. So that is going to be equal to 1 minus, let's see here, we take 0.1 and add to that 0.22 plus 0.4, and that is 0.72. And if you take and you hit in your handy dandy calculator 1 minus 0.72, you will see indeed that is 0.28. So we have ended up with the exact same answer going both ways. All right, let's go put that in. .28 and check our work. Good job. We have all the correct answers for problem number 1. If you have any more questions on this, be sure to send me an email. Thanks.